In previous session, we discussed about natural sampling. Now in this session, we discussed about flat top sampling. For first sampling, ideal sampling width equals to 0, and then next natural sampling, the width not equals to 0, the width is tau, and the top of the natural sampling is not flat, means like it is present like this. In natural sampling, there is noise interference. To overcome that problem, we introduced the next sampling method as flat top sampling. It is the natural sampling, and then flat top sampling means the top of the surface is flat. That is the difference between natural sampling and flat top sampling. Here I wrote that only during transmission line noise is introduced at the top of the transmission pulse, which can be easily removed if the pulse is in the form of flat top. అదే చెప్పాను ఇందాక న్యాచురల్ శాంప్లింగ్లో నాయిస్ అనేది ఇంటర్ఫీరెన్స్ అవుతుంది. సో ఆ ప్రాబ్లమ్ని ఓవర్కమ్ చేయడం కోసం ఫ్లాట్ టాప్ అనే శాంప్లింగ్ని ఇంట్రడ్యూస్ చేస్తాము. ఫ్లాట్ టాప్ శాంప్లింగ్కి టాప్ ఎలాగుంటుంది, కాన్స్టెంట్గా ఉంటుంది. సో the top of the samples are flat అంటే ఏంటంటే యాంప్లిట్యూడ్ కాన్స్టెంట్, సో దట్ దే హ్యావ్ కాన్స్టెంట్ యాంప్లిట్యూడ్. అది కాన్స్టెంట్ యాంప్లిట్యూడ్ టాప్ ఫ్లాట్గా ఉంది కాబట్టి దీన్ని ఫ్లాట్ టాప్ శాంప్లింగ్ అంటాం. హెన్స్ ఇట్ ఈస్ కాల్డ్ యాజ్ ఫ్లాట్ టాప్ శాంప్లింగ్ ఆర్ ప్రాక్టికల్ శాంప్లింగ్. దిస్ flat top sampling is practically possible, so it is called as a flat top sampling. Flat top sampling makes use of sample and whole circuit. This point I will discuss next page. Now this flat top sampling expressed in figures as, now we take first message signal and take a pulsar carrier signal. By multiplying these two we get this flat top sampling signal. And we know up to we discuss about sampling and their definitions. Now we discuss about the mathematical representation of a flat top sampling. Theoretically, the sampled signal can be obtained by convolution of rectangular pulse with ideally sampled signal. So it can be obtained, how it can obtained by convolution of pulse train and ideally sampled signal. And this is a pulse train, this is ideal sampling signal. This is the for ideal sampling with 0, like it like impulse, and then we get this pulse. And the sampler circuit, this sampler circuit contains two gates, and the first G1 gate is called as a switch gate, and the second G2 gate is called discharging switch. Here gate is also called as a switch, and first switch is called as a sampling switch, and the next switch is called as a discharging switch. Here G1 is a sampling switch, output is across the capacitor. Here first two switches are present parallelly, and the output is output across a capacitor which is connected parallelly to this switch. And G1 is a sampling switch, it is always opened and closed for every t seconds equals to sampling time period. G2 is the discharging switch, it is closed after t seconds within t naught seconds duration. Mathematically it represented as y of t equals to p of t into c of t. By applying Fourier transform and solve, we get final equation is this. And up to now flat top sampling is completed. The three types of flat top samplings or three types of modulation techniques are completed up to right now. Up to we discussed about PAM generation. In PAM generation there are three techniques: ideal sampling, natural sampling, flat top sampling. Up to now we are covered about these three methods. In next session we discuss about the PAM demodulation.